Today we're going to talk about absolute value equations and inequalities. So before we actually start solving absolute value equations, we're going to review properties of absolute value. So if I say if the absolute value of x equals 7, what are the possible values of x? So since the absolute value is the distance a number is from 0, 7 is 7 spaces from 0, and negative 7 is 7 spaces from 0. So my answers here are 7 or negative 7. Over here, I had the absolute value of x equals negative 4. So what are my possible values of x? Well, this should be a red flag that I have an absolute value equal to a negative number, which is not possible. So there are no possible values for x that would so the absolute value would equal negative 4, because x cannot be negative 4 spaces from 0. So it's important to remember that if you have an absolute value that equals a negative number, that you do not have an answer. So here are your 4 steps for solving absolute value equations. What we're first going to do is we're going to isolate the absolute value, which means, like in number 3, I have the absolute value by itself equal to a number. So my absolute value here is already isolated. In number 4, my absolute value is not isolated. I would need to get rid of this 17 first, and then my absolute value is isolated on one side of the equation, and all the other numbers are on the other side of the equal sign. Once I do that, I'm going to create 2 cases, because everything from the inside of the absolute value, I'm going to create a positive case and a negative case. So I'm going to actually work through number 3 and follow these steps. So again, I've already isolated my variable, or my absolute value, on one side. So now I'm going to set, as for step 2, I'm going to create 2 cases. So I'm going to say 2k plus 7 equals 3, and 2k plus 7 could equal negative 3. I'm going to solve both of these equations. So I subtract 7, and I get k equals negative 2 over here. I solve over here, and I get k equal to negative 5. So now I have 2 answers. K could equal negative 2, or k could equal negative 5. So now that was step 3 here. So step 4 means to check for extraneous solutions. So what are extraneous solutions? They are solutions that do not work in the original equation. So the important part there is the word original. So I'm going to take my negative 2 and negative 5 and plug them back into my original equation. So here I want to say 2 times negative 2 plus 7, take the absolute value. So this would give me negative 4. Negative 4 plus 7 is 3. Absolute value of 3 equals 3. So that one works. I'm going to check over here for negative 5. I have negative 10 plus 7 gives me negative 3. The absolute value of negative 3 equals 3. So that answer works. So now I've just checked for extraneous solutions. You do need to check because sometimes one of these will not hold true for the original equation, and so it is not an answer. So to write my final answer, I'm going to say k equals, we use brackets because there are 2 possible answers. For my absolute value equation, so k could equal negative 2 or negative 5. If I look over here at number 4, so this is what I was referring to earlier. I need to isolate my absolute value on one side of the equation, which means I need to get rid of this 17, so I will subtract it to the other side, and I will get 6. Now I have my absolute value isolated on one side of the equation, numbers on the other side, so this is where I create my 2 equations. One with a positive answer the same, and then I will negate the answer. So here I get y equal to 7, excuse me, and y equal to -5. So again, I need to check both of these. I plug them into my original equation. So I have 7 minus 1 absolute value plus 17. 7 minus 1 is 6, absolute value is 6. 6 plus 17 equals 23. -5 minus 1 gives me -6. -6 absolute value is 6 plus 17 equals 23. So both answers hold true, so I can write them together. Y equals, we always write we typically write the lowest number first, which I didn't here, but I'm going to start now. -5 and 7. It is not incorrect if you don't write the lowest answer first. It is just our standard way that we like to write them. So here in number 5, I need to isolate my variable, or isolate my absolute value by getting rid of this 16, so I divide it out. So go ahead and take a minute and do 5 and 6 on your own. So pause the video, do 5 and 6, then resume the video to check your answer. So hopefully when you are solving number 5, when I divide my 16, I get my absolute value equal to -2. But this is the exact case we referred to up here. I cannot have an absolute value equal to a negative number. So you could stop right here and your answer is no solution. You cannot have an absolute value equal a negative number. For number 6, you should have worked this through and gotten -10 and 10. They both are valid answers. So now if you move on to number 7, you'll notice that I have multiple n's here. So I still want to follow my same procedures. I want to isolate my absolute value on one side of the equation. So I'm going to add 5n. So I'll have 6n plus 2 on this side. So now I'm going to make my two cases. I'll say 8 minus 2n equals 6n plus 2. Now what I'm going to do is I'm going to set 8 minus 2n, but I need to negate the whole expression here. So I have a -6n minus 2. So that is one important part. You need to make sure you distribute that negative and change the sign of both parts here. So now I'm going to solve my two equations. So I'm going to add 2n over here and subtract 2. So on this side, I'll get 3/4. Over here, I'm going to add my 6n. I'll get 4n, subtract 8. This leaves me with a -5 over 2. I want to check these two answers. I plug them back into my original equation. So if I take 2 times 3/4, so take a minute. You can use your calculator to simplify that if you need to. If you don't, that's fine too. And you should get that this does balance. So 3/4 is a valid answer. So now we're going to come over here. We're going to plug -5 over 2 into our original equation. And you want to check to see if it is a solution. Okay? So take a minute, simplify that. So you should have gotten, on the left side of the equation, we should have gotten 1/2. And on the right side, -1/2. So since those do not equal each other, -5/2 is not an answer. So my only answer in this case is n as 3/4. Okay, so again, that's why it's very important to double check for extraneous solutions, because sometimes you will get one. Go ahead and pause the video, try number 8, and then you can resume the video to check your answer. So hopefully for number 8, you got -9 and -11/5. So now we're going to move on to the back of your paper, which is involving absolute value inequalities. So first we need to remember some of our inequality properties that you should have learned in algebra. So if I have an absolute value of x is greater than or equal to 7, I could have anything in here. So I have x is greater than or equal to 7. So that means any number 7 or greater, I could put in this absolute value and it would hold true. So 8, absolute value of 8 is 8. 8 is greater than or equal to 7. So the trick here is, I know that I could probably put -7 in here for x, and that would also give me 7. So I know -7 works, but I don't know if my arrow should go to the right or to the left. So if you think about it, if I take the, let's say I want to try -4, because I think it should be greater than, because that is what this symbol says. So if I try -4, the absolute value of -4 is 4. Is 4 greater than or equal to 7? No. That is not true, so that means -4 is not a solution. So that makes me think I shouldn't shade to the right. Instead, let me check -8. Absolute value of -8 is 8. 8 is greater than or equal to 7. So I actually shade to the left. So the shortcut is you take the inequality as it is, so x is greater than or equal to 7, and then you flip the sign and flip the inequality sign and to the opposite sign of 7 to make it -7. You should also remember how to do your interval notation. So this looks like a compound inequality. So I have from -infinity to -7, it is an equal to, so I have a bracket that is combined, so it's in union, that's why we use the U, with the bracket on 7 because it's included, all the way to infinity. So this case 1 is what we would call our OR. It is less than or equal to -7 or greater than or equal to 7. Our second example here, it follows the same process. I can say x is less than 4, and then I switch the inequality sign, switch the sign of my number, and I have x is greater than or equal to -4. So if I start with x is less than 4, that would shade to the left. X is greater than -4, that shades to the right. So this is an and, it is less than or greater than or equal to -4 and less than or equal to 4. So my interval notation for this one is easier. I include -4 and then go up to 4 and include that with my brackets. So what does that mean? These look exactly like compound inequalities. So absolute value inequalities are compound inequalities. So you need to brush up on those compound inequalities if you don't remember those. So our process for solving compound or absolute value inequalities is actually really similar to absolute value equations, except for one little difference. So we want to isolate the absolute value on one side. We're going to create two cases, but this one we're going to use this KISS method. We're going to keep it and switch. So what does that mean? If I look at number 1 down here, my absolute value is already isolated on one side. So my first case, I'm going to keep it. Not going to change anything. For my second case, I'm going to keep what's inside the absolute value the same. And now I'm going to switch my inequality to the opposite, and I'm going to switch the sign of the 19 to negative 19. Similar to how we did these. So now I have my two inequalities. So as step 3 states, I'm going to solve both. So over here, I add 3, divide by 2, v is less than 11. Over here, I will add 3, divide by 2, and I get negative 8. So I'm going to go ahead and graph this on my number line here. So I have negative 11, or not a negative, a positive 11. It is an open circle because I don't have an equal to. That will be to the left, and then I have open circle on negative 8 to the right. So is this an and or an or? You can refer up here if you don't remember, but since it's in between, that means it's every number in between these two, so that is and. I'm going to write this in interval notation. You start with the lowest number. So I don't include 8, which means I have a parentheses, not a bracket. All the way to 11, don't include it, so I have a parentheses as well. And that's absolute value inequalities. So in number 2, I don't have the absolute value by itself, so I need to multiply by 4. One important note is if this were a negative 4, I would have to flip this inequality sign here first. So I'm going to multiply by 4. So I'll get the absolute value of q minus 1 is greater than or equal to 8. So now I'm going to set my two cases. So I get q minus 1 is greater than or equal to 8. Then I'll have q minus 1 is less than or equal to negative 8. So again, keep the first one. Then I keep the absolute value, what's inside, switch. I solve both of these. Q is greater than or equal to 9, and then Q is less than or equal to negative 7. So I have 9 here, going to the right, and negative 7 to the left. So I want to say or. Write my interval notation. So it's negative infinity up to negative 7 included, or 9 to positive infinity. Okay. Go ahead and try number 3 and 4. What I will say is be careful here. Once you are getting your absolute value isolated, you will add 1 to both sides, but then here you will need to divide by a negative 4. So actually I'm just going to go ahead and do this one. Just this step so we can be on the same page. I added 1. Now I'm going to divide by negative 4. When you divide an inequality or multiply an inequality by a negative, that means we switch the inequality sign. You need to remember to switch it here right as I'm isolating the absolute value. So my two absolute value inequalities, I make sure I set them up correctly. Okay, so go ahead and finish number 3. Graph interval notation, solve number 4, graph, interval notation. Then resume the video to check your work. Okay, so here are our answers for 3 and 4. So number 3 was an or. I have less than -14 or greater than -4. And number 4 is worked out here. Hopefully you remember to flip your inequality signs when you were solving. So you should get an and. It is greater than -4 and less than 10. So this completes our video portion. You need to make sure you go and complete your knowledge check in Vision with your practice problems there.